we use. Networking devices means to use a network. So what are the different devices we use it? So hub. Next one is repeater.
Switch.
Switch.
Router.
Router. Modem. Like not only this, in networking, we use lot of different devices also there. Okay. So for example, firewall. Firewall is a device to protect your network. IDS, IPS systems, intrusion detection system, prevention system, checkpoints. Okay, it's also like a firewall only. Okay, checkpoints. CSU, DSU, CSU, DSU units. Okay. Okay, different other devices also there. Okay. We'll put a line here. Hub, switch, router, modem. Repeater is nothing but a hub only. Hub act like a repeater. The first one is hub. Hub is a centralized device. Simply, it's like it's a device. Whenever you are connecting to hub to create a small network. Create a small network. So this is the central one. It's nothing but a hub. Okay. Your devices are connected to hub. You want to see how hub is look like. Okay. So this is hubs. Hub and switches, when it is in a small size, can easily little confusion is there. Means it's a hub or a switch kind of stuff. Okay. It's a device. Okay. It is a layer 1 device. Means it's a physical layer device. Comes under physical layer, not physical device. It is everything is physical devices only. It's a physical layer, layer 1, as per the OSI. Okay. As per the OSI layers, OSI layer 1 device. It's a nothing but a physical layer. First, non-intelligent. Non-intelligent device means there is no separate circuit for it. It don't understand about a packet or other things. You don't understand anything. Okay, it just broadcast. It broadcast to everyone. Broadcast means to broadcasting everyone. Its meaning is if A is a PC, B, C, D, E, F. For example, these are the computer. I want to communicate A to B. What happened? It sent this to A to hub. When hub is received a signal, it forward to B, C, F, D, and yes, finally for every device it will send it. And other side means people verify it is belongs to us or not. So what they will do? C, check it. It is not belongs to me. It is not belongs to me. Drop the packet. F, drop the packet. E, drop the packet. D is drop the packet. Of course. B, checked. It is belongs to me. IP address, destination IP address is me. Then it accept the packet. Okay. Same goes with other things. For example, I want to send a packet to C2D. Okay. So here it is. C, send a packet. The packet received to hub. Hub distribute the packet to B, to A, to D, to E, to F. It broadcasts to everyone. Okay. And devices will verify and drop the packet. Not belongs to me. It is 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 belongs to me. Like that. It will accept this packet here. Okay. So hub works like that only. Non-intelligent, it's a broadcast domain suitable for small networks. Like you have 4 computers or 5 computers, no problem. Small networks, no problem. Of course, it is LAN related devices. Okay. Local area network only. We use it okay, LAN purpose only, not for WAN communication. Okay, it's a LAN communication purpose. Not for WAN communication. Suitable for a small networks. Hub is a non-intelligent layer 1 device. It broadcasts to everyone. Broadcast means that one only. Okay. Suitable for a small networks. Okay. Shared when it's a half duplex mode like that. More number of collision occurs, data loss is more. Due to collisions. Meaning is at a time devices are communicating. A is communicating to B, C is communicating to D. But what happened here it is more packets are going through same cable. So what happened? Unnecessary packets because of it is not required to send it to C or D or E, but it is sending. So obviously what happened because of more broadcast, more collisions will occur. So data losses occurs. Okay, so that is a point here. But still, if it is a small network, it is okay to use repeater hub. Hub acts like a repeater. It acts like a repeater. So what is this repeater? Okay, repeater repeat signal. So you can communicate little longer. Meaning is our cable. So here it is a point here we have to put it. Our UTP or STP cable length, supporting length is 100 meters only. Okay. For example, you want to communicate from top floor to bottom floor. It is 100 meters wire is not enough. What to do? Use the repeater. Either you can use hub or a repeater, so then you can able to communicate a little longer distances. Not like I'm in a Pune, then I want to communicate it to Bombay. So then I put a repeaters. I can't communicate. That is not for that purpose. Only thing is only for a short distance, which is little above than 100 meters. Okay. So that is about your repeaters. Next one is we'll go to switches. What is switch? Switch is also same thing as a centralized device. Switch is also same thing as a centralized device, like a hub only. Okay, it's the same diagram only. So just computers are devices connected to switch. Okay, the centralized devices. Okay, A, B, C, D, E, F, anything, no problem. But actually, we can understand by packet traveling how switch will function. But here it is. The connecting, so where it is connected to the switch ports, like you can see the switch ports are there now. The ports are having a numbers. Okay. So when you're trying to search for a switch, computer switch, or computer networking switches like this. So these are the D-Link switch, Cisco switch. If you see, number of ports are generally high port numbers. Okay. So switch is a, as per OSI, it is a layer 2 device. Means data link layer. Okay. Of course, intelligent device used for LAN communication only. Understand MAC address in packet. Create MAC address table. MAT. Okay. Using MAC address table. Okay. With unicast. Okay. By using MAC address table with unicast, the packet forwarding. Okay. So it is a intelligent device, LAN communication purpose only. MAC address table. So what is the last one? You can use it for a small, medium, big LAN networks. Okay. The big also we can able to use it. Means number of switches, number of ports are there. So how it is happens here? Look at here. Initially it is works like a initially it works like a hub, but once it created MAC address table, okay, it unicast packets. We'll see that one. So what is this kind of stuff? Look at A want to communicate it to B, A to B again. Okay, same thing. A send a packet to switch, switch receive the packet and broadcast to everyone. Broadcast to everyone. Like a hub only. But it is, there is a one point here. Each port having a some number, port 1, port 2, port 3, port 4, port 5, port 6. So like this. Each port having a port numbers. Okay, so what it will do when packet is traveling, it create a MAC address table, right? So what it is, port number, means that switch port number and a MAC address. Like this. So it is to create like a port number 1, MAC address of A, MAC address of A, for example A1, MAC address, for just for example for understanding, it create a MAC address. Now for example, B replying for it, okay, or C is communicating to E. Of course, what it will do, it broadcast initially, right? C is communicating C to E. Again, C is connected to 3 and MAC address of C, for example C1, for example C1. Now A is want to communicate to C. Okay, A send a packet to switch and it is directly give it to C. How? Because of we have a C's MAC address and a port number. Okay, so like that, once it is created a MAC address table, we can easily communicate to the devices like this while they are communicating each other. Like that, when they are communicating each other, I got the MAC addresses of port and the devices. MAC address of the devices and their port numbers. Port means switch port numbers. I'll map it. Now, if any device want to communicate to any devices, like A want to communicate it to F or A want to communicate it to E, for example, A to E communication. Take A to E. Now, A send a packet to switch. So in a destination address, there is a E's MAC address. E's MAC address is E1 and it is check is where is E1 is mapped to port number 5. It forward directly to 5 only. Okay, so switch is a device for a LAN communication purpose. Intelligent device, layer 2 device, understand MAC addresses in the packet. So what it will do, it create a MAC address table. Using MAC address table, it is unicast. Comparatively hub, switches, data loss in the switch is less. Okay, data loss is very less in the switches. Okay, number of ports are high. Usually high. Number of ports. You can connect number of ports are high. Okay, so why we need all these things? So this is about your switch. Yeah, so MAC address table, I will put it here, MAT, MAC address table. So port number, guys, these port number are a switch port numbers, not a protocol port numbers. MAC addresses of a devices. Okay. So my port number is 1 and there is a PC is connected. PC name is A1. So PC's MAC address is A1. So MAC address is actually 12 hexadecimals, but for our understanding, I'm writing here. Same example only I'm writing here for understanding. Let's understand how it is works. Like this. If A want to communicate it to B, so it will check the receiving end packet. Guys, that packet, I told in packet understanding it is. So you have to understand basic packet structure. It is like this. Source and destination, right? So source PC, destination PC. My source PC is A, destination is B. Okay. So like here it is. Source MAC address, destination MAC address in the packet. It is like this. Source MAC address, destination MAC address, source IP address, destination IP address. This is the packet. This is the packet structure. Okay. Always like A want to communicate to B. What is the source MAC address? Means APC contains some MAC address. For example, A1. APC having some IP address. For example, .10, .10 or .11. So we are not in the IP address kind of stuff. So just for example, for understanding .11. Destination MAC address is .12. And what is the destination MAC address? Destination MAC address must be BPC MAC address. Sometimes it would FF means NICs, whereas we discussed NICs there only. Now just I will put a one star here. MAC address, broadcast address. Means you don't know the destination MAC address, then we use broadcast address is FF, FF, FF. 3 plus 3. Okay. If you don't know the destination address, so but you are sending, we use the broadcast addresses. Okay. So this is the MAC broadcast address is like that. We don't know the destination thing. Okay. And the structure again remaining is data. So this is the addressing part, but remaining is in a packet. Data is there. Now BPC received. BPC received. Okay. And BPC again want to send a message to you. So BPC MAC address, source MAC address. BPC knows its MAC address, right? And source IP, BPC IP address. Destination IP, APC IP address. And what is the destination MAC address here? APC MAC address. How it is broadcast here? Why it is not a broadcast here? Why it is not a broadcast here because of I received a data. So there is a machine, it's like A is there and this is B is there. I'm talking A to B communication only, not switch or any other communication. Okay, so A is sending a packet, but A don't know B's MAC address at present. Okay, at present MAC address is not. So we use a broadcast address for a destination MAC address, but IP address is we know it. Now finally we send a packet. By replying it, B already received a packet, right? So B already received a packet from A. So the packet contains source MAC address, destination MAC address, source IP, destination IP. Okay. So based on that, it understands the IP address and MAC address. So that's when it is replying, it can use the MAC address to send it. Okay. So this is a little confusion maybe, but understand very simple, guys. MAC broadcast address is FFFF like that. When you are sending a packet, for example, A to B, you send a packet, source MAC address, destination, source IP, destination IP address. If your system don't know what is the destination MAC address, okay, it use broadcast address instead of that one. You send a packet, destination received a packet, destination received a packet. At a destination, so what happened here? At B, I'm writing here. At B, what happened? It maps IP to MAC address. It maps IP to MAC address by protocol ARP. Okay, what is ARP? Address resolution protocol. Address resolution protocol. What it will do? It maps IP address to MAC address. Okay. So at B, we'll put it here only, so it is better. We can write so many things. So at the place of B, in a first time communication, maps IP address to MAC address. So in our ARP table, okay, in a ARP table, there is again ARP table. Okay. So .11 is an IP address, belongs to A1 MAC address. Like this, it will do it. That's why when you are sending a packet again from B to A, so what is the destination IP address? .11. Then what is the destination MAC address? A1. Like that, it knows it. Okay. So that's why in a MAC address table, when systems are communicating each other, the packet contains IP address and MAC addresses. Switch can understand MAC address layer, means data link layer. Okay, it operates at a data link layer. Okay, so it understands the MAC address of source. Immediately they put it in a this position. Okay, immediately it will create a MAC address table. Okay, so that is your packets. Next, so how our destination knows our MAC address? How my destination knows my MAC address? By using ARP protocol. The ARP table maps IP address to MAC address. So whenever you done a one communication, so obviously you received a packet, your system start mapping IP address to MAC addresses. Okay, so that is we call it as a address resolution protocol. So how to check ERP table, ERP space -a. Go to command prompt, ERP space -a to check ARP table. So I'm going to CMD ERP space -a. See it is my network adapter is this one interface. This is my IP address. So this is IP address and their MAC addresses. Currently it is showing very limited with within ourselves only, but if you know how to check it, like I am going to my mobile phone, go to settings. Where is the settings? In the settings, network connections. I select my Wi-Fi name settings. My IP address is 192.168.2.118. I'm pinging to my mobile phone IP address. I'm pinging to my mobile phone IP address. Just I'm pinging. So I don't know MAC address of my mobile phone, but I'm using IP address. Successfully I got pinging. Okay. Now what I'm doing is I'm going to ARP table. See it is 192.168.2.118. This is my mobile phone MAC address. Mobile phone MAC address. Okay. So that is ARPA. Of course, if you see it is dynamic and static. Dynamic means automatically it learn from communication. Means whenever you are communicating from one system to another system, so the system will understand when you received a packet. So you will get the MAC address of other PC. So when you receive, like you received a packet from A, so you know A's MAC address. That's important. This is address resolution protocol. In ERP table, we can enter things like a statically also. Sorry, ARP. See like this. If in case you want to bind statically, you can bind it like this. ARP space -s IP address and their MAC address. So this is for we use for a security purpose. Okay, in like compulsory IP address and MAC address matches, then only we can able to communicate. Okay. This is for a static entry purpose. Okay. Just actually, I don't want to go with ERP, but I went. So what are the device? Hub, switch, repeater, and router. It is next one is modem. Okay, so I will tell about router and modem and we'll finish it. Okay, so very simple way only. As per OSI model, it's a layer 3 device. Okay, it is a layer 3 device. The layer name is network layer. So tomorrow I will explain so different OSI layers also, but IP addresses and OSI layers I will explain. So there you will know what is network layer and all. Okay. It is also intelligent device. It is a inter networking device. It's a inter networking device. It make communication between two or more logical networks. Two or more logical networks. That is a router. Okay. So you have a network. You want to communicate from one logical network or one network to another network. We need a router. So that is router. Make a communication between two or more logical network. Okay. So router do usually routing. Of course, we use it for a LAN and WAN communication, mainly WAN communication purpose. Okay, we use it for LAN communication as well as a WAN communication, mainly WAN communication. Okay, mainly WAN communication. Okay. So here I want to save this picture. Okay. So look at, you have a network. And I want to connect this network to other networks. So how to connect it? Through router only. Okay, through router only. So this is the network, local area network, and this is we connect wide area network. So this is my network limitation. So this is my internal network. So this is my external network. Okay, either you connect multiple networks or you have to use it to connect your outside logical network like that. Okay, so that is the use of router. So mainly WAN communication purpose. Routing is there. So what is a routing? A router do routing. What is this routing? Is nothing but a best path selection. Okay. Packet forwarding. And switching. That's it. And it's not a switch. Switch is different. Switching is different. Okay. Packet forwarding, packet thing. So this will do routing thing. What is the routing is? How to reach the destination. How to reach the destination. Okay. For example, what is this routing? I want to communicate google.com. So google.com server not in a okay. This google.com not in our local network. So we need a internet, right? So what you will do? So our packet or our request should reach to www.google.com. Means the question is reach www.google.com server? It's a big question. So the router will tell how to reach destination. In our case is www.google.com. Okay. So our router will tell how to reach the destination. Is that one? Okay. Router use routing protocols to get to the destination. What are these routing protocols? So generally, like a static, there's a routing. Is certain routing protocols. In routing, we have a static routing. Dynamic routing. Static routing means manually define route path. Route only. It is routing. Route means you're telling a way. Okay. So that is it. Like how to reach the railway station, how to go to Mumbai, how to go to Delhi, how to go to Hyderabad. So that is route, right? So which route you go, by road, by airways, which path you selected, take left, go straight. These are all route only, right? So you define manually, you should go packet like this only. So you define manually, that is a static routing. Only applied for a small organizations. Dynamic routing. It's automatically build a route path using advertisement. Okay. Advertisement means they are telling I belong to this route and all. Dynamic routing uses protocol actually. So that's so we use routing protocols are here. RIP, EIGRP, OSPF. These are the protocols under interior gate IGP protocols, interior gateway protocols are RIP, EIGRP, OSPF. Okay, of course, RIP version 2 we are using. So version 1 is become older. IGRP is also older. So that's why we are using EIGRP. Next, EGP, exterior gateway protocols. Exterior gateway protocols are BGP, border gateway protocol. Yes. Yes. Okay. RIP, EIGRP, OSPF, BGP, ISIS. These are the protocol. Intermediate system, open shortest path first, EIGRP, enhanced interior gateway routing protocol, RIP, routing information protocol. Okay. These are the information about routing. What is routing? It tells the path to reach the destination. If in case I want to communicate to some server, so then we'll do it. Okay, how to okay. How to check the path. So that's the command is trace RT. Put a www.google.com. So obviously, you know how to reach the destination. So go to the command prompt, trace RT, google.com. It is google.com IP address is 142.250, 180.169. You know, the first packet is went to my router. The first one is that pimcom.me 192.168.2.1 is my IP address, my gateway IP address, my router IP address. First, from my system to my router to ISP router, ISP service provider router. Oh, so time. Yeah, this is last. Anyway, okay. So finally it crossed ISP provider. We don't know what is going on. I checked that Kazan India is my ISP provider. Okay, like this. It jumped from one router to another router, one router to another router. Like it will keep jumping. Means it cross some station. Like for example, how to go to Hyderabad from Pune. Okay, so then I get into the train. Train has a route, right? So train has a route. For example, train should pass to down station Solapur, and that is one more village is there, Kalburgi, like that. So Tandur, Nizamabad, or Tandur, where it is that one? Yeah, Lingampalli, and finally Secunderabad. Like that is the route. I want to go to Hyderabad to Visakhapatnam. So Hyderabad, like I get into train in Secunderabad, and next station can be like a BB Nagar or maybe Warangal, Khammam, Vijayawada. Next we'll come with Rajahmundry, Samalkota, Visakhapatnam. Okay, like that. It's like it's a route, right? So same thing. My packet is traveled from my laptop to my google.com. But what is the packet? How it is packet is traveled? It shows here. Okay. So another command is same command only. If you want to reach, like you want to reach facebook.com. Okay. So that is the IP address of facebook.com. Next, same. First my packet go to my router. My router to ISP server. ISP provider, internet service providers. Okay. Look at it. So first IP is same. Second one is also same. I am waiting for a third one. Okay. The stars represent a delay because it should be crossing within a very less milliseconds. Response is timed out. So then we are not getting that information. We didn't get that one. So you can see sixth one onwards. It's a completely different. I got 157, 157, and finally 173 like this. Because route are different from Hyderabad to Pune, Hyderabad to Visakhapatnam, or Hyderabad to Delhi, or Hyderabad to Chennai. Different places, different routes. Sometimes certain part of thing is same, some part is different. So like that. Okay. So trace RT is a command to know how to reach the destination. Okay. How to reach the destination. How you reach the destination. How you reach destination. So we can use trace RT command. Okay. So that's it about your router, guys. So tomorrow some more things I will tell, including modem, use of firewall, what is VPN, like that. Okay. Guys, understand up to now? So today, whatever the discussion we done in a networking.
Yes, sir.
Yes, sir.
Okay, in a single
Yes,
shot,
sir.
it is look like a one. Okay, yeah, very good. Okay, in single shot, it is look a very big one. But once you are go through once today. Okay, I will forward this one also today, and go through once. Go through PPT and go through the notes. Okay,
Yes, sir.
then then you will get it. So once repeated, it is get it. Okay, that's it, guys. Stop recording. Again, I have a batch in afternoon. I forget that when I didn't see in the